Hey everybody, welcome. We are going to talk about audio. Audio, very important, probably more important than video when you start to think about it. But let's go over some of the audio essentials. The essentials of audio is what we're going to go over from the beginning. All right, this is a classic rock band from the 1960s and the 1970s, and we'll talk about them more later. Key audio terms: frequency, hertz, amplitude, pickup pattern, fader, gain, dynamic, condenser, diaphragm. We're going to talk about all of those. What is frequency? It's the rate at which sound moves. That is the measurement that we use to determine the pitch of a sound. And the pitch relates to the highness or lowness of a sound. For example, very high-pitched sound, I just made that high-pitched sound right there, would have more cycles per second and would be considered a higher frequency than a lower pitch sound. A lower pitch sound, such as this, would have longer sound waves, and the waves would happen less frequently. Here's a tone generator, which is always fun for the kids at home. Let's see if it works or not. You guys can play this at home and annoy your neighbors. And let's see. It's a 440 hertz frequency, and this is the sound it makes. If we were to take it down, the human ear can hear between about 20 hertz. Let's see if we can hear 20 hertz. I can't hear anything. 30? I still can't hear anything. Well, I don't know, because my speakers aren't pumped up, but I'm not hearing much. Starting to hear some stuff now. But it is fairly accepted that you can hear between about 20 hertz all the way up to, this is where it gets crazy, 20, okay, I gotta turn that guy down, 20,000 hertz, which is very top end of the spectrum. So those are the two values that we need to keep in mind, because that is the range of frequencies the human ear can actually pick up. You may be able to pick up here. This is a 16,000 range. Let me turn that down again. I can't hear it because as you get older, you tend to lose the higher frequencies and you cannot hear them anymore. So I kind of top out around 10,000 actually these days. You can definitely hear that. Not pleasant. Okay, anyway, that is the tone generator, and feel free to play with that when you're going through the PowerPoint. Okay, so again, the word, a couple words that are all more or less related to each other are frequency, which is the rate at which the sound moves. I like to think about changing the frequency to frequently. How frequently are the sound waves happening? Well, they're happening quite frequently if it's a higher pitch sound, and not as frequently if it's a lower pitch sound. And the measurement we use is hertz, which is abbreviated 8 capital H lowercase z, and it's also known as cycles per second. All right, amplitude has to do with the volume of the sound, and it is measured in decibels. And the abbreviation for decibels is lowercase d, uppercase b. A loud sound, if you're to look at a VU meter, for example, that is one indication of amplitude, volume unit meter. A loud sound will that volume unit meter basically is analogous to the amplitude of the signal, the loudness or the quietness of the sound. Oscilloscope, I believe, is the word I'm looking for. If you were to have an oscilloscope and you were looking at frequencies and you want to determine how loud it was, not only would you look at the amount of cycles per second, but you would actually look at the height of the wave. The higher the wave, the louder the sound. And that's measured again in decibels. All right, here are some sound decibel levels that are commonly found in the world. 0 decibels, well, I'm guessing maybe 1 decibel would be the threshold of human hearing. 20 decibels is kind of like I say recording studio, but it's kind of confined with sound baffling and that kind of thing, so relatively quiet. 50 decibel would be maybe your standard workplace, office space, so that's a comfortable level. 100 decibels is like a subway station, so getting a little bit harder to have a conversation in a situation like that. You know, it's quite loud. 120 is the sound of a chainsaw, and people recommend if you're going to use power tools such as a chainsaw, you should wear hearing protection such as earplugs or muffs, because it could actually damage your hearing, and there's actually a sensation of pain that you can receive from being exposed to sounds that are too loud. 150 decibels is well over the threshold of pain, and that's why you see people that work on in the airport tarmacs, they always have hearing protection. Okay, that's a little of that. Okay, keeping up with volume here. Pete Townsend and The Who earned the title of loudest band in the world, often achieving volumes at the concert of over 126 decibels. That's why I put that picture of them up there, because they were known as the loudest band in the world for a time. Okay. Pickup patterns is our next section. Mic patterns are variable. You use a different mic pattern depending on the job that you need to accomplish with your microphone. Depending on what you need, you might need a narrow pickup pattern where I only want to pick up what is being said in this very small, slice of the environment. And in other cases, I may want to be able to pick up all of the sounds that are happening around me. So if I want to pick up a pattern that is all around, I want to have omnidirectional pickup on my microphone. An omnidirectional pickup pattern, as you can see, it creates like a globe, so 360 degrees around in any direction, you're going to pick up some sound. Whereas the unidirectional, you can see it's much more limited to the rear of the mic. You're not going to pick up as much information, but you will pick up what's in front of it, and it's usually a little bit more narrow. These are the patterns that we are familiar with different microphones. Cardioid is your standard directional mic pickup pattern. Supercardioid gets a little more narrow. Hypercardioid is like what we would consider a shotgun microphone, which is a kind of microphone where you actually point it in a particular direction, and the only information that mic should be picking up is what's, again, in that very narrow strip of direction that the mic is pointed in. Omnidirectional, again, all around. There's something called bidirectional, which can actually pick up equally well from both directions. And then there's hemispherical, which is a mic that you might put on a surface, like a tabletop or a floor, if you're trying to pick up sounds. All right. So going back, so yeah, omnidirectional, unidirectional. Those are the two kind of overarching, and then these are the subcategories of unidirectional. And now we're going to talk about setting up an audio source on the mixer. I actually made a video, and I'm just going to skip through all this stuff because you guys are gonna watch the video. It covers it pretty well, and it's in this module. So, and this is a video about lav mics, how you place them. I would actually ask you to watch that on your own as well. Diaphragm. Okay, that's a term you want to be familiar with. But diaphragm is a very thin, placed right at the very end of a microphone, where the sound waves will hit this little device, which is generally made of some sort of plastic, again very thin, and once those sound waves are hit the diaphragm, it actually creates just a little tiny bit of vibration, which is then transduced or turned into an electrical current. It's then sent through the microphone cable and into a mixer or a camera, where it could be recorded if it's into a camera, or if it's into a mixer, chances are it will be recorded and or redirected into a speaker. So in that case it would be amplified. Microphone, diaphragm. It's that thin element right there. Oops. Skip forward, go back to that. Okay. Two types of mics. Again, not to get you too confused, but there was those two categories we talked about earlier, the omnidirectional and the unidirectional. That has to do with the direction in which sound is picked up. Now here's another two big categories. One is called dynamic, and the other one is called condenser. These are two different types of mics that are essentially achieving the same goal, which is to capture sound waves and transmit those analog sound waves into some sort of electrical current. They just do it a little bit differently, and we'll go over that. So a dynamic microphone, this is the insides of a dynamic microphone. You will see there's actually here's the sound waves coming in. This little device here would be considered like a diaphragm that we had talked about. There's this cone that helps to draw the sound waves into a centralized location. Here's where the power is generated in a dynamic microphone. There's a magnet and a coil, so there's some sort of polarization here that creates an energy current that allows that sound wave to be transduced into some sort of electrical energy form, and then these tiny little wires carry that information back to the whatever location it is that's going to be using the audio, such as a camera or a audio mixer. So magnet, coil, diaphragm, cone. Those are the key elements of a dynamic microphone. You'll notice it doesn't have a battery. That's one of the unique and powerful aspects of a dynamic microphone. It does not require a battery. Condenser microphone, that's the other one. Here is a little bit different scenario. Again, sound waves come in, hits the diaphragm, and then there's this series of electronics within the microphone. Some of the elements include a backplate and a battery, and it basically condenses, it creates a little condenser transducer scenario here, but it's just a little bit different. It's a little bit more sensitive because it actually uses a battery, so it's able to amplify that signal a little bit more strongly and effectively because it has that a little bit extra power introduced into into the transduction system there. All right, so battery is used in a condenser microphone, and they're a little bit more sensitive. Okay, two types of mic: dynamic, they're no battery needed; rugged, so they're used a lot in the field for interviews, vocal performances on music stages. Also for loud sources like bass and guitar amplifiers, they're a little bit more forgiving. They don't have those higher peaks, so it's a little smoother sound, and so they work well with louder instrumentation like guitar amplifiers, drum kits. All right, dynamic, and a condenser does need a power source. There's something called phantom power, which is a source of power that actually is generated from the camera if it's plugged into a camera. There's the cable. I don't have a cable with me right now, but the XLR cable actually is able to provide a string of current or electricity that is sent back to the microphone, and that actually enables that transducing without putting in a battery, which is really nice. Sometimes you don't want to have to worry about batteries all the time. They cause a lot of trouble on the set when you're trying to shoot things and your battery goes dead. All right. Other good thing about condensers is they can be very small. So our mics that are in our telephones and everything are condenser mics. They're not quite as durable as dynamic mic, but they have better frequency response, which means they can have a little bit more responsiveness to sounds on a larger spectrum of the frequencies, higher and lower frequencies. Okay, there's a little quiz there, you can look at that. All right, and okay, types of connectors, moving right along. XLR is the most commonly used. It's a 3-pin connector. It's what's called a balanced signal. There are 3 pins in here, and I'm not going to get into too much detail, but it does allow you to transfer audio information along a cable very well insulated, which means doesn't react to interference from outside sources like electrical interference or radio interference. Again, having to do with the way the wiring is configured, they've found a way to basically kind of eliminate the interference through the wiring within a balanced XLR cable. So these are the most widely and commonly used types of connectors for microphones. All right, and other audio mixing devices. XLR is the preferred method. Phone connectors, this is kind of what that looks like. There's usually a larger one that's 1/4 inch and 1/8 inches, like the old school headphones that you have on your phone. TRS stands for tip ring sleeve. These are used for headphones. They're also used for instruments. Oftentimes they're unbalanced, which means they're not as protected from interference. And this one, it actually uses 3 wires. An unbalanced signal only uses 2 wires, and it is much more susceptible to audio interference, and it's only really good for shorter cable runs as well. So you can't run a phono connector cable very far without creating some issues. So these are good for short runs, less than 50 feet. Here's a couple more. BNC is a connector that's used with SDI cables. This is traditionally a connector that has been used with video, and now it's currently being used with SDI cables, which carries both video and audio. These are the old school RCA connectors. You may have a fond recollection of those from your youth, pre-HDMI days when you had to plug in your games and whatever you may have into your device, your TV usually. Usually there's one for video and then left and a right audio channel. These are very much consumer grade. You don't see you never really see RCA connectors in a professional setting. All right, that's it. So these are the current key terms. You can look those up. And here's some more key terms. I'll put a link as well to the Cyber College. I'm sure they'll have definitions for all of these as well. All right, that's all for today. Thank you, guys.